Hello everyone. Today we will discuss replacement model considering time value of money. Let us see the basics of time value of money. Suppose today we deposit certain amount P in the bank for n years with an interest rate I. Then at the end of n years we will be getting final amount F equals to P into 1 plus I raised to n. For example, suppose today we invest rupees 1000 in the bank at an interest rate of 10% for 5 years. What will be the final amount at the end of the 5th year? So here P is equal to rupees 1000, I is 10%, that is 0.10 in decimal, N is 5 years, and we have to calculate what is the future amount or final value. So F will be equals to 1000 into bracket 1 plus 0.10 bracket raised to 5, and we will get the future amount as rupees 1610.51. So here we can see that the present value of 1000 is changing to 1610 in future after 5 years. Okay. Now in the reverse, suppose after 5 years from today we are getting rupees 1000, okay, at an interest rate of 10%. Then what is its value today? So here F is rupees 1000, that is the future value which we are getting after 5 years. I is the interest rate of 10%, that is 0.10 in decimal, and N is the number of years, that is 5 years. So 1000 rupees we are getting after 5 years. So what is the present value of those 1000 rupees? That is P, what we have to calculate. So again using the same formula, F is equal to 1 plus P into 1 plus I raised to n. Now rewriting the formula in terms of P, we can write P is equal to F into 1 upon 1 plus I raised to n. So this multiplying factor 1 upon 1 plus I raised to n, this is called as a present worth factor or discount factor. So when we multiply this factor to the future sum, we are getting present value of that particular future sum. So for this example, P is equal to 1000 into 1 upon 1 plus I, that is 0.10 bracket raised to 5. So here we get the value of P as rupees 620.92. Okay, that means future amount of 1000 rupees is equivalent to the present value of 620.92. So from about two examples, what we see is the value of money changes with time. This means present value is equivalent to the future value, or future value is equivalent to the present value if we consider time value of money. This also means the purchasing power of today's money is equivalent to the purchasing power of the future amount if we consider the time value of money. Similarly, the value of money or purchasing power of money is reducing year by year because of inflation. That means the purchasing power of today's 100 rupees is more than purchasing power of the 100 rupees after n years. Okay, and why this is? Because of inflation. Because whatever the, suppose we are purchasing any particular item in 100 rupees today, and if we go into the market after 5 years for purchasing the same item, okay, but it will not, its cost will be now increased because of inflation. So it is not of 100 rupees, it may be 130 rupees or it may be 150 rupees. So purchasing power of today's 100 rupees, which was more, but after 5 years if we go into the market and try to purchase the same item with the 100 rupees, it's not possible. We have to pay some more money. That means the purchasing power of 100 rupees is going on reducing year by year because of inflation. So this is the basically the concept of time value of money. So we have to keep into mind this concept. Now in replacement model, when we are considering time value of money, there are some typical types of problems. One of the problem is the item has no scrap value or salvage value. This kind of problems may be there, or the items which has the scrap value or salvage value. Okay, now when the scrap value or salvage value is present, there are again the sub two types are there, that is scrap value or the salvage value is constant and the scrap value or salvage value is variable. So these are the typical problems into this. Now let us see the replacement model considering time value of money without scrap value or salvage value. Here the scrap value or salvage value will be 0. Okay, so basic assumptions for this kind of problems are the item has no scrap value, and second assumption is the maintenance costs are paid in the beginning of the different years. Okay, so here beginning of the different years, this is very important. Okay, so maintenance cost, if it is paid in the beginning of the year, it has different meaning and different calculation. Similarly, the maintenance cost, if it is paid at the end of the year, then again the discount factor is changing. So here just see that our assumption here that maintenance cost is paid in the beginning of the different years. Okay, now to calculate now the weighted average annual cost for the item, we will go step by step. The procedure is, first we have to find out the present value of the maintenance cost for each of the years. Okay, then calculate the cost plus accumulated present value, that means the cumulative present value of the maintenance cost for each of the years, and then find the cumulative present value factor or the discount factor for each of the years. Then last step, find the weighted average annual cost by dividing the value of step 2 by step 3. Now the rules for replacement. So here first rule is the item should be replaced. Item should be replaced if the next year's weighted average cost is greater than the weighted average cost of the previous year. And second assumption or the second rule is the item should not be replaced if the next year's weighted average annual cost is less than the weighted average annual cost of the previous year. If these criterias are fulfilled, as per the criterias, we can say that whether in which year we should replace the particular item. So to understand the concepts, let us take one example. A machine costs rupees 500. The maintenance costs are 0 for the first year and increase by rupees 100 every year. If the machine is worth 5% every year, determine the best age at which the machine should be replaced. The resale value of the machine is negligibly small. So what is given? The cost of the machine is given, which is 500 rupees, that is C equals to 500. Okay. Another thing is given is the money is worth 5% every year. That means interest rate is given. I is equal to 5% and that is equals to 0.05 in decimal. And the resale value is negligibly small, that means the resale value is 0. So here S will be equals to rupees 0. So these are the given things into the example, and now we will try to solve the example. Okay, so let us, for solving the example, let us take M is equals to maintenance cost, DFM equals to discount factor for maintenance cost, and this is given by 1 upon 1 plus I raised to n. DM, that is the discounted maintenance cost, and this will be calculated by M, that is maintenance cost, multiplied by discount factor for maintenance cost. Okay, that is M multiplied by DFM. Okay, then next is cumulative discounted maintenance cost. Okay, then next is DTC, that is discounted total cost. So this total cost, how we are calculating, that is the cost of the machine which is paid one time in the initial year, and then the discount adding with this is discounted maintenance cost. So total will be this discounted total cost. Okay, this is C plus DM. Cumulative discount factor for maintenance cost. So this will be taken. And finally, the weighted average annual cost we will calculate, that is discounted total cost divided by cumulative discount factor for maintenance cost. Okay, so in this way we will solve the example. Okay, now first of all, to find out the discounted maintenance cost, okay, we want to calculate, first we have to calculate what is the discount factor for maintenance cost. Okay, so how the discount factor for maintenance cost is calculated? Its formula is there, 1 upon 1 plus I raised to n. Okay, so now let us see how this discount factor is calculated for each year. So given into the example what is there, ki in the first year the maintenance cost is 0, which is given. Okay, and in later on from second year onwards the maintenance cost is increasing by 100 rupees. Okay, so in this table we can see that the maintenance cost is for first year it is 0. Okay, maintenance cost for the second year it is 100 rupees. Then maintenance cost for the third year it will be increased by 100, so it is 200 rupees. Okay, then maintenance cost for the fourth year it is 300 rupees, and maintenance cost for the fifth year it is 400 rupees. These costs, these are paid in the beginning of the year. Okay, so this 0, this is for this first case, that is maintenance cost for the first year, it is 0. Okay, it is at the beginning of the year, that is first year. Similarly, 100 rupees we are paying in the beginning of second year. Okay, in this way we have to understand now this. In the above table, now here we have written the same cost. Okay, here year n we are considering now this is from 0. Okay, why this is? Because as per the timeline, if we see when this particular cost is we are paying, so basically this cost we are paying in the beginning of that year. So from the timeline, if we see, this 0 shows us that it is a start of the year 1. Okay, 0 time shows the start of the year 1. Now from this, now year 1 ends. Okay, here. Okay, so at 1 here the year 1 ends. So year 1 ends, but at the same time year 2 is starting at this point. Okay, similarly year 2 will be now ending at this point at 2. Okay, and year 3 will be starting. Okay, similarly at n equals to 3, here the end, this shows us the end of the year 3, and similarly at the same time it shows us it is a start of the year 4, and n equals to 4, it shows us end of the year 4 and start of the year 5. Okay, in this way we have to now understand the concept of this timeline. Because why? Because this is the whatever the amount of the maintenance cost, these are paid in the beginning of the year, and that is why we have to consider in this way first. Now when we are calculating the discount factor for the maintenance, that is DFM, we want to now calculate. So here what is our formula is for the DFM? It is 1 upon 1 plus I raised to n. Okay, now if I take this now into this formula, what is n here? What is the n value? So n value will be 0. Okay, for this first value of the DFM. Okay, and maintenance cost for that first year, it is 0. So it is a starting of the year, starting of that year, it is basically. So it shows by 0, n equal to 0. This shows the start of the first year, and whatever the value the maintenance cost we are paying, that is at the start of the year. So discount factor for the maintenance cost, this value when we are calculating, so here it will be I, as we know I is 0.05. okay, so we will put the values now here. So it is I is 0.05 and n is here, it is 0. okay, so this value will be equals to 1. okay, as because it is raised to, this is power is 0, that means this value becomes 1 denominator, and so numerator is 1 and denominator is 1, so we have this value is 1. Similarly, now if we go into the n equals to 1, n equals to 1, in this case this represents the start of the year 2, okay, and end of the year 1. So at the start of the year 2, how much maintenance we are paying is 100 rupees, okay, so which is given here also. So now we can take now here n equals 2 into the equation. Here we can take now n equals to 1. okay, so n is 1, this one that we are using here into the equation, and this value is equals to 0.9524. okay, okay, in the similar way, now if we go into the next year, that is start of the year 3 or end of the year 2, this is, that is n equals to 2. So here now we can take the n is equals to 2 into the equation, and we can find out what is the discount factor value, and this will be equals to 1 upon 1 plus 0.05 raised to 2, this we get 0.9070. okay, now going into the next year, that is n equals to 3, that means it shows the start of the year 4 and end of the year 3. okay, so it shows the start of the year 4. So we will take n equals to here into this equation 1 upon 1 plus 0.05 raised to n is 3. okay, so this value will be 0.8638. Similarly, for the n equals to 4, it will be the end of the year 4 and start of the year 5. It shows start of the year 5. So here we can take now n equals to 4 into the equation, and then the values will be 0.8227. 0.8227. okay, so in this way the discount factor for maintenance should be calculated. okay, now we have calculated the discount factor for the years. So now we will proceed to solve the example by drawing a table. So let us take the values in a tabular form. In first column we have year n, in second column it is cost of the item C. Third column maintenance cost M. Fourth column discounted factor for maintenance cost DFM. In fifth column discounted maintenance cost DM. In sixth column cumulative discounted maintenance cost. In seventh column discounted total cost DTC. In eighth column cumulative discount factor. In ninth column weighted average annual cost. So this weighted average annual cost will be given by column number 7 divided by column number 8, that is discounted total cost DTC divided by cumulative discount factor for maintenance. Okay, so this is column number 7 divided by column number 8. So we are getting weighted average annual cost. Okay, first of all, into the year column we are writing year from 1 to 5. Then cost of the machine. The cost of the machine which we have paid is rupees 500, which is a one-time cost. Okay, so this will be written, okay, 500 for every calculation. And now maintenance cost for the year 1 to year 5. So which is written 0, 100, 200, 300, 400 as given. Okay, now keep in mind that these costs are paid at the beginning of the year, and this year is also considered in the same way, 1 to 5. So when we are doing this calculation for year 1, that means this cost is paid at the beginning of the year. Okay, that whatever the calculation we have done in the previous table, that we are now going to rewrite here. Okay, now the discount factor for the maintenance cost DFM was what we have calculated for the year 1. So year 1, for the year 1, so our first value of the discount factor is 1 as we have calculated. Now second value from the table, okay, just if we see, first value is 1, second value is 0.9524. Okay, so this value just I will put it here. Then for the year 3, this value is 0.9070. Then for year 4 it is 0.8638, and for the year 5 it is 0.8227. Okay, so whatever the values we have earlier calculated, these values we have written here into the table. Now we will calculate discounted maintenance cost. Discounted maintenance cost, how we are calculating? So maintenance cost multiplied by discount factor. Okay, that is column number 3 multiplied by column number 4 values. Okay, which is given here. Okay, so 0 multiplied by 1 for first case maintenance cost, it is 0. In the second, the maintenance cost is 100 multiplied by discount factor 0.9524. So this value is 95.24. Next value 200 multiplied by 0.9070. So this value will be equals to 181.40. Then next value is 300 multiplied by 0.8638. So this will be 259.14. And last value 400 multiplied by 0.8227. So this will be 329.08. Okay, so we have calculated the discounted maintenance cost. Okay, that means what we have done here is these values are at the end, at the beginning of those years, respective years. Now we have calculated the present values of these values, present value of these okay, that we have calculated. So present value of the 100 rupees, okay, which we have paid in the beginning of the second year, okay, we have paid 100 rupees as a maintenance in the beginning of second year. Its present value is what? How much is this? It is 95.24 rupees. Similarly, when we have paid 200 rupees, if we are paying in the third year, its present value of 200 rupees will be equivalent to 181.40 rupees. Okay. In the same way, we have to understand this. Now the next step is, we have calculated the discounted maintenance cost. Now we have to calculate cumulative discounted maintenance cost, so that we will calculate the total. We have to calculate total cost for that case. So cumulative discounted maintenance cost, we will start writing for this 0. We will write it as it is 0. Then next value is 0 plus 95.24. So it will be 95.24. Next value will be 95.24 plus 181.40. So this will be equals to 276.64. Then 276.64 plus 259.14. So this will be 535.78. Okay, and then 535.78 plus 329.08. So we will get 864.86. Okay, so we have calculated the cumulative maintenance, discounted maintenance cost. Okay, now we have to calculate what is the total cost. Okay, that is discounted total cost or total cost. So it will be what? The how much cost we have paid for the machine. Okay, so in the first year, how much we have paid? We have paid 500 rupees as its cost of the machine, which is one time. We have already paid that. Now what we are paying? Maintenance cost. Okay, so for the maintenance cost for the first year, at the beginning of the year, is there any maintenance? No, maintenance is 0. So how much we have paid is now is 500 plus 0. That means column number 2 plus column number 6. Ye values, those values we have to add. Okay, so here 500 plus 0. So first is 500. Okay, now in the second year, we have already paid the cost of the machine, that is 500, and what we are paying into the second year, we are paying the maintenance cost. Okay, so maintenance cost, how much we have paid is discounted maintenance cost. We have paid 95.24. okay, in the second year, and in the previous year, that is year 1, it is 0. So that is why we have to take the cumulative discounted maintenance cost. So we have to add the 500 plus this cumulative discounted maintenance cost. So 500 plus 95.24. So this value will be equals to 595.24. Okay, why cumulative? Because we are calculating this value, this particular, this much cost we have paid at the end of second year, or we can say in the second year. So this cost we have paid in the third year. So we have already paid rupees 500 as its cost of the machine, and then plus the cumulative discounted maintenance cost. Okay, so this value we will get 776.64. okay, the next value will be 500 plus 535.78. so this value will be equals to 10 35.78. And last 500 plus 864.86, we will get 1364.86. Okay, so this is what we have got, the total cost whatever we have paid. For the year 1 we have paid 500. In the year 2 we have paid total how much? Up to the year 2 how much we have paid? 595.24. Up to the year 3, considering year 1 2, total how much we have paid? 776.64. Okay, in the similar way we have to understand this. Okay, now cumulative discount factor, that is this discount factor what we have calculated into the column number 4, discount factor for maintenance cost. So we will take the cumulative values of this discount factor. So first value will be 1 as it is, then this 1 plus 0.9524, so this will be 1.9524. okay, so next value will be 1.9524 plus 0.9070, so this will be equals to 2.8594. then next value 2.8594 plus 0.8638, so this will be 3.7232. and the last value 3.7232 plus 0.8227, so this will be 4.5459. Now the weighted average annual cost, this will be calculated by the formula. What is this? Column number 7 divided by column number 8. So column number 7, the values are these are the column 7 values, and column number 8 is this one. So we are dividing this column number 7 values by column number 8 values. So we will get weighted average annual cost. So for first year, the weighted average annual cost is 500 divided by 1. So this will be 500. Okay. So for the next year, the weighted average annual cost will be 595.24 divided by 1.9524. So this value will be equals to 304.88. For the third year, the value will be 776.64 divided by 2.8594. So this value will be 217.61. Okay, for the fourth year, so value is 1035.78 divided by 3.7232. So our value will be 278.20. And in the last fifth year, 1364.86 divided by 4.5459, so it will be 300.25. okay, so now we have calculated weighted average annual cost. So for the first year, the weighted average annual cost we are paying is 500. For the second year, we are paying 304.88. Then for third year, we are paying 217.61 rupees. For the fourth year, we are paying 278.20. And for fifth year, we are paying 300.25 rupees. So from this, if we see the weighted average annual cost, this column, we can see that the values are reducing, okay, up to year 3. Okay, so this means up to this is the minimum value, okay, from the table for the year 3. Okay, and from here onwards, again the values are increasing. That means the annual average cost, the cost is increasing. So the minimum cost we are getting is 217.61, which is at the third year. Okay, so at the end of the third year we are getting the minimum cost, okay, that we are paying to retain that particular machine. Okay, so from the criteria, if we see, we can replace the item, that particular machine, at the end of third year, because the previous year cost, how much it is, 304, which is more than this value. Also the next year cost is 278.20, which is also more than this value. That means it is suitable to replace the machine where we are getting the minimum cost. Okay, so we are getting the minimum cost here. In first year we are not replacing because first year we have paid 500, then in the next year we have paid 304, we are going to pay 304, but the value is lesser, it's reducing by the previous year, so we can retain the machine. Similarly, in the next year, in the third year, the value is again reducing. That means the payment, the cost is reducing, so we can retain the machine up to the third year. But if you see in the fourth year, the cost is increasing now. Okay, so it is not feasible to retain the machine, okay, beyond this third year. And that is why we can say that the minimum cost is we are getting at the year 3, and so we can replace the machine at the end of the third year. So this is what the answer we can say. From the above table, the minimum weighted average cost is rupees 217.61 at the end of third year. So as per the rule, the annual cost of the fourth year is more than that of the year 3. Also the average annual cost of the year 2 is also more than that of the year 3. So the machine should be replaced at the end of the third year. Okay, so that's all. This example is over. So we will see into the next video the new types of examples.